Hello, class. We are going to start the packet that I gave you right before spring break. You're going to need to watch the videos, take notes. When you're taking notes, you should not be listening to music or trying to do anything else. Watch the video, take notes. When I say pause the video and try a problem, make sure that you pause the video and try a problem. You're really going to have to take this on and try to be really serious about watching these videos. I will be available through Teams or through email, so if you have any questions, if a certain example doesn't make very much sense and you want me to go over it again or go over it in a different way, email me, message me through Teams. Make sure that you communicate with me. It's going to be very important that you communicate with me whenever you can. All right, so first of all, logarithms. If I gave you this equation, 2 to the x equals 6, and said, figure out what x is. Right now, the only thing that we could do is try if it was a 2 squared is 4. 2 to the third is 8. So it has to be a number between 2 and 3. And we would just have to guess and check until we found that number. Logarithms allow us to undo an exponent of x. Logarithms are kind of like the xth root, because if we square something, we can take the square root. If we cube something, we can take the cube root. If we raise it to the x, we can take the logarithm, and that will undo it. So here's the definition of a logarithm with base b. The log base b of y equals x. And I want you to see how I wrote that. I'm going to put gray lines in here. So this is the line of my paper. See how the b is slightly below that? The b is subscript. It's slightly below the line. Make sure that when you're writing your base, you write it slightly below the other thing. It is not log b to the y. That means something totally different. You have to make sure the log is on the line, the y is on the line, that base is slightly below, subscript. Now, this is equivalent to b to the x equals y. And I'll use light blue to show how you would convert these from one to another. If you have a logarithm and you want to convert it to exponential form, you would do b, the base, raised to the x equals y. So do you see that kind of swoop? I call that the log ride, and I'm going to be really stupidly silly with this because honestly it works. But start with the base and woo, do this little curly Q all the way around. And yes, I want you to say woo like that as you are doing this. But b, look at the order that I touch things with this little woo curly Q. B to the x, notice over here, b to the x. And then it comes around the equal sign and ends up equaling y. You can also do the log ride with exponential to change it back into logarithmic. So b to the y, woo, log base b of y equals x. The other thing is I should probably write down how you say this. This is said log base b of y equals x. I have been known on a test in the past to write something like log base 3 of 9 equals 2 and say, write this out using words, and then it's like a bonus question. Hint, hint, wink, wink. First thing we're going to do is rewrite logarithms in exponential form. You need to get really good at switching forms. So if it has a log, it's logarithmic form. If it has an exponent, like 4, 5, and 6, it's written in exponential form, and we have to be able to switch between the two. So if we've got log base 3 of 9 equals 2 and we need to switch it, start at the base 3 and woo! We're going to start with the 3 raised to the 2 equals 9. That little log ride woo thing shows you what order to write those numbers. The next one. Actually, I'm going to do number 3. Woo! 5 raised to the negative 2 equals 1 over 25. I want you to pause the video and try number 2 on your own. Okay, so, woo, 8 to the 0 equals 1. How'd you do? Now let's go backwards. Let's rewrite in logarithmic form. And this is where I want you to be really careful how you are writing the logs. So, woo, draw your little thingy. We start by writing log. So write log like it's on a line. Log base 6. You start with that 6. The next number you write is 36. That's in line with the log, equals 2. So if you were to draw like a line on notebook paper, log 32 and 2 should all be on the same line. The 6 should be smaller and slightly below that line. Let's try number 5. Woo! Log base 16 of 1/16 equals -1. And if you want to put the 1/16 in parentheses, you can. Okay, pause the video, try number 6 on your own. Okay, woo! Log base 125 of 25 equals 2/3. Okay, evaluate the expression. Set it equal to x and rewrite it as an exponential equation first. We need to figure out what power would make this work. So if we put this equal to x and then did the log ride, woo, this would be 3 to the x equals 81. So what number, if we raise 3 to that exponent, will give us 81? 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. So that x is 4. That means that log base 3 of 81 equals 4. If we could type log base 3 of 81 in our calculator, it would tell us 4, and then we would know 3 to the 4th equals 81. This next one, woo, 2 to the x equals 16. 2 squared is 4. 2 to the 3rd is 8. 2 to the 4th is 16, so this one is also 4. And then the last one, woo, 4 to the x equals 64. 4 squared is 16. 4 to the 3rd is 64. Now, these logs all have bases. There is something called the common logarithm. If you see something like number 10, do you see how right down here there's no base? If you see a log with no base, that means that it is base 10. So this log with no base means that it's base 10. We simply write log to be log base 10. And if you look at your scientific calculator, there is a log button. That log button is base 10. There's also a natural logarithm. Natural logarithm is related to e. It has a base of e. So remember when we learned about the natural base e, when we had the natural base e, that's related to the natural logarithm. You can write it log base e, but it's more often just ln. ln means log with the natural base. So when you see ln, you know that it is base e. So using your calculator, you can evaluate both of these. And I will show you my graphing calculator, but you can use your normal scientific calculator for this. You just have to find the log button and the ln button. You should already know, You should already know where the ln button is because we used it when we were calculating e. Log is usually a button really, really close to that. So log button 5, the log of 5 is 0.6989700, etc. Let's round to 3 places after the decimal. So that would round to 0.699. Oops, I should write it in pen. So approximately 0.699. ln, that's the button that we already know about because of e. ln of 0.1 is negative 2.303. We would round it to 0.303. So approximately equals negative 2.303. Now I want you to pause the video and actually try this using your calculator. Whatever calculator it is that you are using right now, find the log button, find the ln button, and give this a try. Make sure that you are getting the correct decimals. Once you feel like you're getting it, then play the video and move on. If you cannot figure out how to get these entered in your calculator, message me, like put a comment on Teams or email me or something, and I will help you figure out what you need to do. Logs and exponential functions are inverses of each other. We've done inverse functions before. Inverses, that's where we like switch the x and the y. So number 18, f of x is a fancy way of saying y equals. To find the inverse, we need to switch x and y. So y becomes x, and x becomes y. Now, because of how we do the log ride, it's really easier if the equal sign is over here on the right. So I'm going to put equals x. I'm just moving that x to the other side, which is fine. Now let's do the log ride. Woo! 3 to the x equals y. The inverse is 3 to the x. Okay, let's try the inverse for number 19. Actually, follow those same steps. I want you to try number 19 on your own. So pause the video, try number 19 on your own. Pause it, pause it, pause it, pause it. Okay, so this is y equals log base 8 of x. We're going to switch that to x equals log base 8 of y. And then I'm just going to write equals x on the other side because it's easier to do that log ride going to the right. Woo! 8 to the x equals y. So our inverse is 8 to the x. Okay, number 20. Y equals ln. Anytime you see ln and you're going to do something with it, I just want you to rewrite it as log base e. ln really means log base e, and you need that base when we do that log ride. Okay, switch it around. X equals log base e of y plus 3, and then I'll just put my equals x on the other side. Woo! E to the x equals y plus 3. We need to get y by itself, so our next step would be to subtract 3 on both sides. So e to the x minus 3 equals y. And again, just to make it look nicer, put the equals y on the other side. There's our inverse. I want you to pause the video, try number 21 on your own. Be brave, give it a try. Pause the video. When I see ln, I think about that it's log base e, switch x and y, and then I'm just going to write equals x over on the right side because it's easier to do that log ride when it's on the right. Woo! E to the x equals y minus 10. Add 10 to both sides. And then y equals e to the x plus 10. Your assignment is going to be on Big Ideas Math. I'm going to do my best to give you as short of an assignment as I can with the best problems that I can find on there. And I'm going to try to give you some answer checks if possible. So get onto Big Ideas Math and start working on that assignment. There'll be a help session tomorrow on Teams. Make sure you're looking for when that is. And then email me with questions. The worksheet packet that I gave you before spring break, that I'm going to leave as extra practice for you. I will be posting the answer keys to those worksheet packets on Teams. So if you want extra practice to make sure that you're really good at this, you can use that worksheet as extra practice. The answers will be posted on Teams.